All right, so here's our first question. It says, at a stop sign, some drivers come to a full stop, some come to a rolling stop, and some do not stop at all. We would like to test if there's an association between gender and type of stop, full, rolling, or nonstop, or no stops. We collect data by standing a few feet, yada, yada, yada. There's the data below. It's in the form of a matrix, okay? We have columns and rows. So when you see matrix, that should kind of set off that we're going to do a chi-squared test, okay? If you see a matrix. So if you go to stat over to our test and up to chi-square test, not goodness of fits, that's when we're given lists. So we're given matrices, chi-square test, it wants an observed and an expected. So before we actually do that, we're going to go put this information into our matrix. So you'll see here you have the matrix word above this little x, or I'm sorry, the x to the -1, the x inverse. So I'm going to hit that. If you have anything in there, I like to just reset the calculator. It's just the easiest way to do it. So I'm going to hit second memory. I'm just going to do reset, all RAM, reset. And they should be gone, matrix. Okay, so now I'm going to go to edit, back to matrix, edit. I'm going to edit matrix A. And I'm going to put this information into matrix A. Okay, so this is a 3x2 matrix, 3 rows, 2 columns. So I'm just going to put the data in 6, 6, 16, 15, 4, and 3. Once your data is in there, you do not need to do anything with matrix B. The calculator is going to put the expected, this is our observed, it's going to put the expected values into matrix B. So I'm going to hit stat over to test, chi-squared test. My observed is A, my expected is going to go into matrix B. I'll hit calculate. Okay, I don't really need any of this stuff. Okay, what I need is the values from matrix B. So if I go to second matrix and go down to, or actually I'm going to go to edit again, down to matrix B and hit enter. Okay. And it says if the gender is not associated with this type of stop, so that's basically saying what will we expect? How many males would we expect to not stop at all? Males not stopping, notice in this matrix is the bottom left entry. So on our expected matrix, it's going to be the bottom left entry. So we would expect 3.64 males to not stop at all. Bottom left, bottom left. Okay, question 31. Let me resize this. At the beginning of the semester, we collected some data from you. 2 of the questions on the survey were about gender and whether or not they have equal, more or less energy in the afternoon compared to the morning. Below are the results. Again, we have a matrix, okay? Not a list, a matrix. Assuming that gender and energy levels are not associated, what is the expected value? So this is going to be done the same way as the last one. So I have stuff in these matrices. I'm going to start by resetting my calculator. 7, all RAM, reset. Go to matrix. I'm going to edit matrix A. This is a 2x3 matrix, and just put all the observed values in. Okay, I'm going to run my test, stat, chi-square test, yada, 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 calculate. I don't need any of this stuff. I'm going to go back to the matrix menu, over to edit, matrix B, and it says, what is the expected value for the number of males that have equal energy? So again, it wants bottom left box. That's going to be 10.071. Okay. All right, this says professor using an open source introductory statistics book predicts that 60% of the students will purchase a hard copy of the book, 25 will print out from the web, and 15 will read it online. She has 200 students this semester. Assuming that the professor's predictions were correct, calculate the expected number of students who will read the book online. Well, if her calculations are correct, it says 15% will read the book online. Well, there's 200 students, so what is 15% of 200? That's just going to be 30. 30 students. Don't overthink that one. Okay. 36. Let me resize this thing. Yikes. All right. Bring it back down. It says researchers studying the link between prenatal vitamin use and autism surveyed the mother of a random sample of children aged 24 to 60 months with autism, conducted another separate random sample for students with typical development. The table below shows a number of mothers in each group who did not use the prenatal vitamins during the yada yada yada. Okay, we don't need this total column. All right, that's just going to throw you off. So it says state the appropriate hypotheses for tests for independence of use of prenatal vitamins during the 3 months before pregnancy and autism. So we want to assume they're the same. We're going to try and prove that they're not. So that's why you got this one right. We're just trying to show that they're different. It doesn't say one's better than the other. It's just that they're different. All right, so we're going to complete the hypothesis test with our test statistic. Okay, so no, the bottom's also a total, so we don't need this bottom either. So we have a 2 by 2 matrix. Okay, 2 by 2. So again, we're going to go clear out our memory, 7, 1, 2. Clear, go to our matrices, over to edit A. We have a 2 by 2. So we say 1, 1, 1, 70. Oops. No, darn it. Maybe adjust that one. 70. 143, 159. Okay, run our test. Stat over to chi-squared test. Calculate. All right, so it says now this says there's actually a typo in the computer. I just double checked this. The computer has 2.96, but this is really our chi-squared test statistic. So you can write 8.86. It's going to mark that wrong, but it shouldn't mark it wrong on the quiz or problem set. I believe those are correct. For some reason, they have 2.96 here, but that's not right. And then our p-value to 4 decimal places is 0.0029. Okay. All right. And then you can use that to answer I think the last one's a multiple choice. All right. And then we have here, let me fix this again. It says yada, yada, yada. Open source textbook, 60%, 25.15. End of the semester, we asked students to complete a survey where they indicate what format the books they used. All right, yada, yada, yada. There's 126 students. That's the first thing you want to keep in mind here. 126 students. Here's the percentages the professor thinks is going to happen, and here's what actually happened in the numbers. So state the hypothesis for testing if the professor's predictions were inaccurate. So we're going to assume his predictions were accurate. Number of people who buy it is 60. Number of people who print it is 25. And number of people who read it online is 15%. And then we're saying that at least one of the claimed probabilities is different. We can't say they're all different. We're just trying to show that one of them is different, that he's just wrong. Okay, he's not 100% correct. So then here's how many students he observed using each format. What did we expect? Well, he expected 60% of that many students to use the hard copy. So we'll say, it says do not round. So let's clear this out. We have 126 times 60%, 75.6. We expected 75.6 students to buy a hard copy. He expected 25% would print it out. 126 times 0.25, 31.5. And he expected 15% to read it online. 126 times 15%, 18.9. So we have a matrix, or I'm sorry, we have a list now, observed and expected. So now we're not going to use the matrix, we're going to use the stat list. We're going to edit our lists. So L1 is going to be observed, so that's 71, 5, 15, our expected 75. Oh, I don't want to do that. Darn it. Can't use a backspace here. Whatever. I don't need that list. Let's do 75.6, 31.5, 18.9. So now we go to stat over. We're not going to use this chi-square. We're going to use a goodness of fit test. Our observed values are in L1, expected are in L2. Degrees of freedom is the number of categories minus 1. So this will be 2. And we're going to calculate. So we get a test statistic of 2.43. And we get degrees of freedom associated as 2. I believe that's all the questions for that one. There might be some questions based on the p-value, but your p-value is 0.2973, which is high. So you would fail to reject HO. And the last one, is this the last one? Yes. Okay, so we have pulling data from 2001 and 2010. It says, state the hypothesis for the following research question: have beliefs on the origin of human life changed since 2001? So we're saying these two things are the same, and then we're trying to show that they're not. So we could say the population follows the 2001, population follows the 2001. So it's not this one. It's not the middle one. That's 2010. We're trying to show that it does not follow 2001. It has changed. So we have question 1,019 adults. Observed in 2010, we're going to take each of these percentages and put it into each of these boxes. You'll take 30%, 38%, 1,019 times 38%, 387.22. Nearest whole number with 387. You'll do that for all these. And then expected, if these two are the same, the expected would be if they're the same, you would expect these percentages to hold up in 2010. So you would take 37%, put it here, 12%, put it here, 45%, so on. So you'll do 2001 percentages, and this will be 2010%. And then you're just going to use your chi-squared goodness of fit test. Once they're in L1 and L2, your observed will be these numbers in L1, your expected will be these numbers in L2. Degrees of freedom will be the number of categories minus 1, so that would be 3. And then you can calculate and get all your information there.